Good afternoon, everyone. So we start with section 2 today, fourth lesson, that is memory organization. So in the first section, we had seen in the first lesson that what is computer system and what is the structure of a computer system. In second lesson, we have seen how do we operate with the ALU, or how does the ALU operate and performs all the arithmetic and logical operations for a user using the algorithms. Then in the third lesson, we had seen the CPU part, that is the control unit of the CPU, how it is designed by using hardwired and microprogram concept. We have seen what are the register of 8086 and 80386 microprocessor. If they are of 8086, we have them with 16 bits, and if it is of 80386, we have them as extended version with 32 bits. Then we have already covered the ALU part of the CPU in the second lesson. So in the third section 2, that is in the fourth lesson, we'll be covering the memory organization of our computer system. So what all memories do we have? The primary memory, that is RAM, the secondary memory, the cache memory, all the memories we'll be studying in this memory organization. So we have two types of internal memories inside the system. One is the SRAM and another is the DRAM. So the primary memory of our system, we have memory basically divided into cache memory, which is inside the processor itself, and it is considered to be as the fastest memory. Then next, apart from that, little bit more size is there in our primary memory, which is our RAM, which stands for random access memory. We have seen how the contents can be accessed randomly, since the data is stored in the memory cell where we had rows and columns. So every row and column has an address, that is 00 at row and 00 at column. So the complete address is made as 0000. Similarly, for next we have next row we have 01, and if it is same column we have 00. So the address is made as 0100. So if you all remember that memory diagram which I had drawn in the word. So if it is RAM, why it is called it as random? Because we can pick up any memory location. For example, if I want to choose a memory location 1111, and if I want to take a data which is there at 1111, I can directly go to that location 1111 and take the data. I need not have to access it in a sequential manner. Therefore, it is considered to be as a random access memory. Then if it is secondary, we have seen we have CDs, DVDs, pen drives, hard disk, and so on. But out of it, we also have one more memory called as ROM, that is read-only memory. That means we cannot change the contents of those memory. It has already been written by the manufacturer when we buy the computer system. Okay, but if it is RAM, random access memory, a user is allowed to change the contents as and when it is required. We also call them as a temporary and a primary memory. Temporary means once it is written, we cannot generally change. Therefore, ROM is considered to be as permanent memory. But if it is temporary, means what? We can keep on changing as per our requirements, and the RAM is considered to be as primary memory. So the RAM which we have, which is temporary, which can be changed and as and when user requires, that RAM is divided into two parts, the SRAM and the DRAM. Okay, S stands for static random access memory and D stands for dynamic random access memory. So this S is for static and D is for dynamic. Static means it is constant and dynamic means it keeps on changing. Now, if you might have a question that since it is RAM, how can it be static and how can it be changing? So we will see this when we see the individual diagrams ahead. But for now, just remember that SRAM is static, which keeps on, which where the data is static, that means constant, and DRAM is dynamic RAM, where the contents keep on changing dynamically. Therefore, it is called as dynamic random access memory. So we have SRAM, which is generally used for the cache memory. So whenever I have a data which comes from the cache memory, I will keep that cache memory's data inside my SRAM. But if I have a data coming from my any other data coming from a user, I will keep that user data inside the DRAM. Okay. So if it is cache memory, I use SRAM. But if it is a user related information or a user related data, I will try to save it in DRAM. Once if that DRAM is filled up, I go to my hard disk, pen drive, and so on. Okay. So these are the two internal memories. Internal means you have cache memory also internal, but when I talk about RAM as internal, I have SRAM and DRAM, out of which SRAM generally stores the cache memory data and the DRAM stores the main memory data, which is the user information related data. Whichever a user gives for execution, all those user related execution data is kept inside the DRAM. Now, what is SRAM? It is much faster as compared to DRAM. So the speed in which your SRAM operates, it is faster. Therefore, it is given to the cache memory. So which memory is the fastest in our system, it is a cache memory. So next, after the cache memory, the next which is fastest is our SRAM memory. Therefore, we generally store the cache related information in the SRAM. So since cache is faster and we store that cache into SRAM, so your SRAM also has to be faster as compared to your DRAM. But if you see cost wise, it is much expensive as compared to your DRAM cell. Okay, so the DRAM is much more cheaper as compared to your SRAM memory. Then if let me talk about characteristics of a memory system. So whichever memory we have just spoke up till now, the cache memory, RAM memory, your ROM, your hard disk, your pen drive, whatever types of memories we have, secondary, primary, registers, and all those memories have certain characteristics. Now, what are those characteristics? First is the storage capacity. What is storage capacity? Is nothing but how much size of memory or how much size of a data can be stored inside that particular chip. So if it is RAM, it will have some storage capacity. If it is ROM, it will have some storage capacity. If it is secondary memory like hard disk, it will have some storage capacity. If it is cache memory, that also will have some storage capacity. That means how much number of words or bytes of information I can store inside it is considered to be a storage capacity. Your one byte is 8 bits and your one word is 16 bits. So how much bits of information or how many number of bits I can store will be recognized by the storage capacity of that particular memory system. So every memory system, let it be your cache, your RAM, your ROM and secondary, all of four have different storage capacity. Depending upon that much capacity, utna amount of data is stored inside that memory chip. Okay. Next, we have unit of transfer. This is a second characteristics. Now, what does a unit of transfer means? How many number of bits are being read or written in a single operation. So, if I have an instruction called as move a comma b. So, for this instruction move a comma b, how many number of bits are read and how many number of bits are written? That is considered to be unit of transfer. So, if move a comma b takes 8 bit of data to read and 16 bit of data to write, that means I consider the entire thing of moving 8 bit and writing 8 bit or moving 16 bit and writing 16 bit as unit of transfer. Okay. Next is access mode. Now how the data can be accessed. Okay, so we have four different access method. First is random access. That means you pick up any memory location and you take the data. Second is sequence. That means though if you want to access the 1000th memory location, you have to first read 0, 1, 2, 3 and then go and read 1000, that is in line. Then we have direct access and associative access. This also works with a memory address. How are they going to work? That we will be seeing at the end of this lesson. Okay, so we have four access method. We know random access, that is you go to any memory location and take the data. Sequences, you have, even if you want to go and access any location, you have to start reading the data from the location 0000. Direct and associative access also works on the memory location like random access, but they are little bit different as compared to random access. So how they are going to work, that we will be seeing in the end of the lesson. So we have four access methods. So any memory which is stored either in cache, secondary, main or inside your any other memory system ROM, every of them can use any of this access method to access the data. Okay. Next we have access time. What does access time mean? The time required between the request made for the operation and the time the data is made available or returned to the location is called as access time. Now, in short, what does access time means? If I have given a request for executing a program addition of two numbers, so the time when I give the program to the system, then second I give a input 2, second number I give a input 3, and until I get the output 2 plus 3 5, how much ever the time the system takes to take the number, calculate and give you the output is considered to be as a access time. So it is the time between the request made for executing till the response received or answer written into any memory location is considered to be as a access time. That means जब से request दिया है और जब तक final result display हुआ, जितना भी time system ने लिया, that is considered to be as a access time. Okay. Next we have performance of storage. Now performance of storage means how does your SRAM and DRAM work in terms of storage. मतलब SRAM कितना store करता है, DRAM कितना store करता है, how they are going to store in SRAM, how they are going to store in DRAM is considered to be as performance. That means SRAM, if it is better, we say performance of storage is better in SRAM. But if DRAM is better, we say performance of storage is better in DRAM. So how this performance is judged depending upon how much it stores and how much and how it stores. Okay. So both of this we will be studying little after we complete this characteristic. Okay. So just remember, we judge the performance based on how much we can store in SRAM and how much we can store in DRAM. तो अगर DRAM में ज्यादा स्टोर होता है तो we say performance of storage is better in DRAM. बट अगर हम SRAM में ज्यादा स्टोर कर सकते हैं तो we say that the performance of storage is good in SRAM. Okay. Then we say cycle time. This is the next characteristics. What does a cycle time mean? Minimum time elapsed between two consecutive read requests. It is same as the access time. Now your cycle time and this access time is same. Okay, what was access time? And from time from when I have given the request till I get a response is considered to be as a access time. But what is this cycle time? Minimum time elapsed between the two consecutive read. So if I have a program addition of two number where the first instruction is move a comma b, second instruction is move b comma c, third instruction is add a plus b. So when I read move a comma b and when I read move b comma c, the time taken between this two read operation is considered to be as a cycle time. So if you compare what is access time and cycle time is individual time taken to read multiple instruction, and access time is time when I request and I get a response is the access time. Are you understanding the difference between both? Cycle time means if I have 5 instruction, time taken to read all the 5 instruction is the cycle time. But access time is the time I have given the input and I have got the output is considered to be as access time. Then last is data transfer rate. What is data transfer rate? How many bits per second the data is transmitted is considered to be as data transfer rate. So if RAM transmit 12 bits per second, but if cache memory transmits 13 bits per second, so I say that the data rate of cache memory is more than the data rate of RAM. Okay. So how many individual bits I can transmit in per second tells me what is the data transfer rate of a particular memory chip. So the data transfer rate of your cache memory is different. For RAM, it is different. For ROM, it is different. And for second memory, it is different. Okay. Then apart from this, you also have some physical characteristics. What are those physical characteristics? They keep on changing depending upon what type of memory it is used. Okay. So we may have some semiconducting memories. We have magnetic disk, we have magnetic tape, and we have compact disk. Okay. Compact disk is CD. Magnetic tapes and magnetic disk were used before the CDs and DVDs were used. And then you have something called as semiconductor memory. Now let us see for all of 4 of these memories, what is the access method, what is the performance of storage, and what type of storage does it use. So if it is semiconductor memory, I can access that memory in the random access form. That memory is volatile. And how is the data stored? The data stored is in the form of electronic medium. That means I use some electronic medium to store the data. Have you started with your CN? Do you have CN in this semester?
But only the first lesson is conducted. After that, the lectures are not conducted.
Only first lesson is completed.
Yes, sir.
Yes, ma'am. And for the second one, the recordings are posted.
Okay, so have you come across the topic types of communication medium or types of networking medium like fiber optic, coaxial cable, and twisted pair? Yes or no? Are you all there? See,
Yes, ma'am. Ma'am,
if it is not
think-
straight away, no, I will explain. I don't mind. Just give me the answer so that I can understand.
Yes, ma'am. Please explain.
no.
Ma'am, please explain.
Okay, fine. So what is happening now? हमको इंटरनेट कैसे मिलता है? I am connected to you all are connected to me. ठीक है? We both are exchanging some data. I am exchanging PPT, that is digital data is exchange. I am exchanging voice also, that is analog data. I ask you something, you might transfer me digital data in the form of files and all, or you might speak to me in a voice. That is, you say yes, no, that is voice. Okay. So how is this communication happening? It is either twisted pair or coaxial cable or fiber optic. Nowadays we generally use fiber optics. ये जो 3G है, 4G है, 5G जो नेटवर्क्स है, ये नेटवर्क्स क्या यूज कर रहे हैं? दे मेक यूज ऑफ फाइबर ऑप्टिक. Now what is that fiber optic? Data is transmitted in a form of light. You might have heard in physics, light is the fastest medium for traveling. So what is that? What does that fiber optic cable uses? It uses light for transmission. तो जो डेटा है 0 and 1 वो कैसे ट्रांसमिट हो रहा है? लाइट से ट्रांसमिट हो रहा है. देयरफॉर इट इज फास्टर. ठीक है, लाइट ग्लो हुआ मतलब बिट 1 आया, लाइट क्लोज हुआ बंद हो गया मतलब बिट 0 आया. So that is how your fiber optic works. If it is coaxial and twisted pair, they both are very slow as compared to fiber optic because they do not make use of light. कोएक्सियल केबल में क्या है? कॉपर वायर्स यूज होते हैं. कॉपर वायर यूज करके डेटा कॉपर वायर पे डाला जाता है एंड देन ट्रांसमिशन हैपेंस. बट इफ इट इज ट्विस्टेड पेयर, हाउ इज ट्विस्टेड पेयर डूइंग? आई एम यूजिंग टू केबल्स, आई एम ट्विस्टिंग दोस केबल्स क्रिस क्रॉस में एंड देन द डेटा इज ट्रांसमिटेड. Advantage of using twisted pair is what? Advantage of using coaxial and fiber optic is what? You generally do not have miscommunication or crosstalk. Crosstalk matlab kya? Abhi many a times if I am on a call with you, there is some third person, I can hear the voice of third person also. Many a times it happens. Nowadays it is not happening, but we could hear this during landline. So what is that? That is nothing but called as crosstalk. When two persons are talking, but I can still hear the third person's voice. That is what is crosstalk. So ये crosstalk avoid करने के लिए we started making use of coaxial cable and fiber optic cables. But why was this happening in twisted pair? Because we were twisting the cables. जो cables है उसको ऐसा हम लोग twist करके use करते थे transmission के लिए. तो उसमें ये problem आता था. तो to avoid that problem, we started using coaxial cables and fiber optic. But why we have stopped both and started using only fiber optic is because since light is used in the transmission and light is the fastest medium for transmission, therefore we make use of light. Okay. So what I'm talking about here in this slide is semiconductor memory uses electronic. Electronic medium is used for transmission. Electronic means it is charge. Zeros and ones in the form of a charge. When it is magnetic, that means some magnetic bits are used for transmission. But when it is optical, optical means light is used for transmission. So if you see CD में भले data store कम है, but उसका जो access time है, retrieval and storage, that is more as compared to any of these mediums. Why? Because it is using light as compared to your electronic charge and magnetic fields. Okay. So what is that optical? It is uses fiber optic. But whereas what is that magnetic and electronic? It may be used twisted pair or electronic coaxial cable or in form of a charge. Okay. So if it is semiconductor, I can access any data anytime. And the medium used for storing and accessing the data is in the form of a charge. If it is magnetic disk, direct access method is used where I use medium for storing as magnetic fields. Again, if it is magnetic tape, data is accessed in a form of a sequence. You might have heard cassettes, which we used to put it in our radios, and we had a button play, pause, rewind and stop. Play means it will play track number 1. जो CD के पीछे print किया है अगर first song XYZ, so it will play that song XYZ. अगर stop किया तो it will stop that song. That means it will stop the radio itself. But if I pause तो वो point पे pause करेगा. But if I say rewind तो वो थोड़ा पीछे जाके वही XYZ play करेगा. But did I had any option of playing directly track number 10 or song number 10 in tape? No. So same thing was happening in magnetic tape. If I was storing a data in a magnetic tape, even if I want to read tape number 10, I have to first read 1, 2, 3, 4, 5, 6, 7 and then read tape number 10. Therefore, the method used was sequential. How was the data stored in the form of a magnetic fields? But if it is compact disk में can I play any of a track? Yes, I can play any of the track. अगर track number 10 है तो double click on track number 10. Whichever song is there on track number 10, it will start playing. Why? But again, there was no lagging. Lagging means what? जैसे ही click किया, the song will start playing. Whereas in magnetic tape, it may take certain time to load. Why? Because again, there is a difference in the term of storage. Here I am using magnetic field, but here I am using light. Since in light, the data transmission and receiving is faster. Therefore, it is much more retrieve access time and cycle time is more in compact disk as compared to any of these magnetic or any of these types of memory system. Okay. What is direct? We will be doing in the slides ahead. What is volatile and non-volatile? I think every one of you are now aware about volatile and non-volatile. It is temporary and permanent type of memory. Okay. Next we have memory hierarchy. Memory hierarchy means how were these particular memories used. पहले क्या है, सबसे पहले we started using registers. So we have seen many registers in 8086 and 80386. So every processor has a register, which is a very smallest part of a memory or a smallest part used for storing the data. मतलब उसका memory size is very small. उससे थोड़ा बड़ा किसका है, cache memory. After cache memory, it is a memory inside the processor. Okay. Then we have main memory, which is our RAM. Then we have these magnetic tapes and magnetic disk, which are secondary. So this register and cache, these are the internal memory. Okay, inside the processor itself. Main memory is your RAM. You purchase and you put it in your motherboard. Then you have secondary memory like your hard disk, but in that also you have different levels. We started with magnetic disk, magnetic tape, CDs, DVDs. Then we started using hard disk. Then we started using pen drives. All this comes. Okay, so there, this is hierarchy is what you have internal. You have primary memory, which is RAM, and then you have secondary memory. So any computer system with a CPU will have this kind of memory hierarchy only. What will keep on changing is this secondary memory. Nowadays, you will not find magnetic disk and magnetic tapes. You will not even find floppies and CDs. You will only generally find DVDs, pen drives, your hard disk and all. Okay. So these are replaced as the era or the time keeps on changing. But this part, last part is always reserved for your secondary memory. Okay. Is this clear up till here?
Yes.
Yes, ma'am.
Okay, so
Yes, ma'am.
we have seen memory. We have started with SRAM and DRAM. We know that SRAM stands for static, DRAM stands for dynamic. Both of them are internal memory. One is used for user related data, other is used for cache memory. We have seen characteristics of a memory. Let it be any memory, RAM, ROM, secondary, primary, kuch bhi memory hone do. All the memory has this characteristic: cycle time, access mode, then data transfer, unit of transfer, storage capacity. Every each and every characteristics is there for each and every memory. We have also seen the memory hierarchy. Now we will start with what does SRAM mean and what does DRAM mean and how do they actually work. Okay, can you open the book which is shared with you on your system so that it becomes easy for looking into the diagrams? Is the book available to everyone? Can you
Yes,
all
ma'am.
hear? Yeah, please open that book. I
Ma'am,
will
we are
also.
on.
Okay. Those who can open, it will be good for you so that you will be able to see it properly. I am also opening. Zoom your system screen, sorry, so that you will be able to see. Can you see this SRAM cell block
Ma'am,
diagram?
page number.
Page number 4.5, 4 of 5. Can you see figure 4.2 block diagram of 1-bit cell? Can you all hear me?
Yes, ma'am.
Huh. What is happening? You have 4 signals over there. That is, one is
Ma'am,
in.
can you zoom it
I
little
have
bit?
already zoomed it, but if
Okay,
I,
ma'am.
oh, just give me 1 minute. I've zoomed it to
Can
400.
use the plus button here.
Sorry,
The magnifier.
sorry.
The magnifier of the drive, use that one.
Now can you see?
Yes, ma'am.
And you can reset the web page size now.
Actually, I on the second half of the screen, I am looking at you all. So if I open that, I won't be able to see you all. Can you see the what is written at least?
Yes, ma'am. Yes, ma'am.
हाँ ठीक है. So if you see the figure number 4.2 block diagram of 1 bit memory cell. Now how is your memory working? You have four things: input, output, select line, and read write line. Okay. Now what is input? Input line, that means it is allowing you to give your input, whatever program or whatever
And you can
instruction.
see it.
Sorry,
The text which
That
is
zoom switch is coming in middle, ma'am.
that has it gone now?
No, ma'am.
Just a minute.
and now it's visible.
Visible?
Yes, ma'am.
Everyone, for everyone it is visible. Okay. See, now you have an input line, you have an output line, you have a select line, and you have a read write line. Okay. What is happening in a read write line? Oh, sorry, what is happening in the input line is whatever input a user gives to the system, every input is taken one by one through that line. Whatever output that particular input generates that particular cell generates is being taken out from the output line. Okay, so the input accepts the input, whatever output that input generates is being thrown out to the output line. Okay, now what does the select line do? The select line is either set to 0 to value 0 or it is set to value 1. Now depending upon that 0 and 1, your read write signal gets activated. Okay, when your select is 0, which means what? Read write will not do anything. But when your select line is 1, your read and write will activate, and it will start performing read as well as write both. So let it be any memory cell. Every memory cell will be performing this in continuation till your program does not generate a final output. So input will be taken from input line, output will be generated from output line. As soon as the input is being selected by the input line, your select signal also starts working. Either it will be set to 0 or it will be set to 1. If it is set to 0 means the read write line does not have to work, but if it sets to 1, your read and write can be doing the work of reading as well as writing. Once the work is completed, again your select line will be set to 0. So if whenever the cell performs, the select line is 1. Whenever the cell is inactive, the bit is set to 0. Okay. So that is how your memory cell works. Now again, each and every memory cell will keep on changing depending upon what it is used. Either we use SRAM or we use DRAM. Some more components will always keep on getting added. But this cell part or the working of this cell part always remains common. Maybe in SRAM, few more things are added or few more hardware is added. In DRAM, again, they might remove something. So this keeps on changing. Hardware part keeps on changing from memory to memory, but every memory will work on the basis of this cell, where we store the value either 0 or 1 inside this particular cell. And how that cell works depending upon the input activation of select, which further activates your read and write signal. Okay, is that clear? Yes or no?
Yes, ma'am.
So, ma'am. Yes, ma'am.
Okay, then next, just a minute, where is the PPT? Can you see the PPT?
Not yet.
No,
No,
ma'am.
ma'am.
Yes or no?
No, no.
Okay. Can you see it now?
Yes, ma'am.
Yes, ma'am.
Okay. Now, those who have the books, can you come to page number 414? Sorry, 414. Page number 414. Those who do not have the book will look here. Can you see the diagram? SRAM on page number 414. Yes or
Can
no?
you zoom into the
Ma'am, zoom to.
Can you see?
Yes, ma'am.
yes, ma'am.
Okay. So you have two diagrams here. A part is DRAM and your B part is SRAM. Again, on this page 415, you have one more diagram, logic diagram for a cell. Can you see that? 415, logic diagram of a cell.
Yes,
Yes,
ma'am.
ma'am.
Okay. Now what is happening? Again, here also there is a memory cell. This is also a memory cell. But as I said, your memory cell will keep on changing depending upon you use primary memory, that is RAM, or you use ROM, or you use secondary memory. Okay. Now what is happening over here? Is JK flip flop and all flip flop completed in your DE?
Ma'am, it started yesterday.
Okay.
Sorry, in the Friday.
Okay. ठीक है. What are we trying to learn over here is, can you see the select line on the top of the diagram?
Yes, ma'am.
Yes,
Can you see the input on the left hand side of the diagram and output on the right hand side of the diagram?
Yes, ma'am.
Yes,
Okay.
ma'am.
At the bottom of the diagram, we have a read write line. So now if you compare this four things with the memory cell that we just studied, is all the four things there inside this memory cell? Yes, we have input also, we have output also, we have select also, and we have read write also. Along with that, we have some two AND gates and we have a JK flip flop also. Okay. Now, how is this entire memory cell going to work? As I get an input, select line will be activated. Select line will activate this read write line. This read write line, if you see in the diagram, it is connected to these gates G1 and G2. Can you see? Read write line is cutting connected directly to your G1 and G2, and your select line is also getting connected to your G1 and G2. Can you see these things in the diagram?
Yes, ma'am.
Yes, ma'am.
Okay. So what am I going to do is, when I give a input, along with this input, your select line will activate. Your select line will also give some input to your AND gates, that is G1 and G2. Along with that, your read write line will also give some inputs to your G1 and G2. After that, your G1 and G2 will work with this flip flop JK, and then it will generate the output. So from the diagram, what you can see is your SRAM uses a concept of flip flop. That means your SRAM cell stores your data or stores your data inside the memory in the form of flip flop. What is that flip flop? It is one bit memory cell. Do you know what is flip flop? It is one bit memory cell. That means how much information I can store? I can store only one bit of information into it. So what is that one bit? Either I can store 0 or I can store 1. So when I store 0, it will keep on remaining 0 till the data is not changed. Once if I change the data to 1, it will keep on storing 1 until I again do not change the data. Therefore, it is called as static RAM. Why static? जब तक 0 है तब तक 0 ही चलेगा. Change किया तो वो 1 change करेगा. Again 1 will only continue unless and until I do not change it to 0. Therefore, it is called as flip flop. Oh, sorry, SRAM, static, and which uses a concept of flip flop, which stores the data either 0 or 1. Whatever it stores, it will continue storing until and unless it is not changed. Now, how does it work? See here. You have come to this diagram on page number 4.14b, static RAM cell. Now, in this static RAM cell, what do we have is, we have bit lines B and B bar. Okay, one is input, one is output. You have some address lines, you have power supply as DC voltage, and you have one negative ground connection. Okay. Apart from that, in the diagrams, can you see T1, T2, T3, and T4?
Yes, ma'am.
T5, T6 also. What are
Yes,
those?
yes.
Those are transistors. Okay. T1, T2, T3, T4 are transistors. Now, how are these transistors connected? They are connected in a cross-coupled manner. Cross-coupled means ये जो C1 है ना, वो T1 और T3 के जगह पे T2 और T4 को भी connected है. Again, if you see this C2 is connected to T1 and T3 also, along with T4 and T2. Okay, the cross couple. Can you see a cross?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
हाँ, ग्राउंड के ऊपर जो क्रॉस बना है, why it is called as crossed couple? Because they are connected in a cross way. That means they are individually also connected, but they are connected in a cross way also. Okay, now let us see that if C1 is low, see the C1 and C2 can turn high and low depending upon the input. ठीक है, अगर वो लो है तो क्या इफेक्ट हो रहा है, अगर हाई है तो क्या इफेक्ट हो रहा है, that we are going to see now. Okay, if it is low means it is 0, and if it is high means it is 1. Can you see 0 and 1 written with a pencil there?
Yes, ma'am.
Okay, so when C1 is low and C2 is high, which means what? C1 is 0 and C2 is 1. Low means 0 I said, and high means 1. तो जब C1 लो है तभी C1 का वैल्यू क्या है, 0, और जब C2 हाई है तभी C2 का वैल्यू क्या है, 1. Now we just have to see कि what values are going to these transistors. Okay, ट्रांजिस्टर कौन से है, T1, T2, T3 और T4. ये चारों ट्रांजिस्टर में से कौन से ट्रांजिस्टर काम करेंगे और कौन से नहीं करेंगे, that we are going to decide based on the value of C1 and C2. So now I know that value of C1 is 0, which is low, and value of C2 is high, which is 1. तो अगर C1 0 है तो C1 किसको कनेक्टेड है, C1 T1 को भी कनेक्टेड है, T2 को भी है, T3 को भी है, T4 को भी है. ठीक है, बट इफ यू सी चारों को कनेक्शन किसी किसी को डायरेक्टेड है, किसी किसी को इन्वर्टेड है. इन्वर्टेड मींस कैन यू सी दैट बबल, इन्वर्ट का बबल, yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes,
What is
ma'am.
that? Where is that invert? Invert is there only on transistor 3, T3 and T4. Invert is not there in 1 and 2. So invert means what? The bit will change. And मतलब जिधर bubble है, we call it as inverter, and the bit is getting changed. जिधर inverter नहीं है, bit is getting transmitted directly as it is without changing. So now tell me, when C1 is 0, what will be the value of T1? The value of T1 will be also
1.
0. नहीं,
0.
उधर
Okay.
लिख के मत बोलो, उधर गलत लिखा है. Do not look at the pencil diagram and tell me. Only observe the pencil का written work on C1 and C2. When C1 is 0, what is the value of T1? The value of T1, it is going as it is. Inverter है क्या? नहीं है. तो 0 अगर पास किया है तो T1 को क्या मिलेगा? 0 ही मिलेगा. Correct? Now tell me the value of T2. C1 जब 0 0 जा रहा है, again it will be 0 only. Why? Because it is not getting inverted, it is going as it is. Are you understanding?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes. So when C1 is 0, at that time T1 and T2 is also 0. But when C1 is 0, what is the value of T3? It is
One.
getting changed from 0 to 1. Why? Because of that inverter. Again, when C1 is going to T4, the value of 0 is getting changed to 1. Correct?
Yes.
Yes,
So
ma'am.
what is
Yes.
happening when C1 is high? When C1 is low and C2 is high, at that time transistor T1 and T2 are 0, and transistor T3 and T4 are 1. Yes or no?
Yes.
Okay, but now what did I tell you? We have to check both things. We have to check C1 also and C2 also. अभी हमने क्या चेक किया? सिर्फ C1 चेक किया ना, C2 चेक किया क्या? नहीं किया. So we have to check both of them at the same time. So now repeat to me, listen to me again. When C1 is 0, at that time T2 is 0. Yes or no?
Yes.
Yes.
Think and tell, huh? Girls, be attentive. When C1 is 0, T2 is 0. True or false?
True.
True. Okay. Again, I repeat, when C1 is 0, at that time T4 is 1. When C1 is 0, T4 is 1.
Yes.
True.
Yes, because you
True.
had a
Yes,
हाँ,
ma'am.
you had
Yes.
an inverter, so value got changed from 0 to 1. Now I tell, when C2 is 1, T1 is also 1. When
Yes.
C2 is 1, T1 is also 1.
Voice.
When C2 is 1, T1 is also 1.
True.
True.
Why?
True.
Because हाँ C2 से जो 1 निकला है वो एज इट इज T1 को जा रहा है, बिकॉज T1 डज नॉट हैव अ इन्वर्टर, सो अगर 1 दिया है तो 1 ही मिलेगा. करेक्ट. Again I say when C2 is 1, T3 is 0.
True.
True. Correct. Why? Because 1 was sent but it had an inverter, so it got changed to 0. Now you come to these lines and look at the diagram. When in the logic state 1, logic 1 मतलब चालू है, 0 मतलब close है. ठीक है. We have 4 transistors T1, T2, T3 and T4 which are cross connected in order to get a effect of a flip flop. फ्लिप फ्लॉप को हमने कैसे बनाया है, ये जो 4 ट्रांजिस्टर है ना उसको ऐसा क्रॉस में कनेक्ट करके हमने उसको फ्लिप फ्लॉप बनाया है. क्यों फ्लिप फ्लॉप बनाया है? बिकॉज इट इज SRAM. SRAM uses flip flop. So to make a flip flop we have used 4 transistors and we have connected it in a cross way. Okay. Now when it is logic state 1, मतलब जब भी वो हाई है, तभी हमने क्या किया है, वी हैव सेट द वैल्यू ऑफ C1 एज 1 एंड वैल्यू ऑफ C2 एज लो. डू नॉट लुक एट दिस पेंसिल डायग्राम, पेंसिल का राइटिंग, द पेंसिल का राइटिंग आई एम चेंजिंग नाउ. व्हेन C1 इज हाई मतलब C1 के पास क्या है, 1 है, और C2 के पास क्या है, 0 है. आर यू आर अंडरस्टैंडिंग?
Yes, ma'am.
Yes.
नाउ यू टेल
Yes,
मी.
ma'am.
Now you tell me when C1 is 1 and C2 is 0, what will be the values of T1, T2, T3 and T4? What it is written over here? T1 and T4 are off, T2 and T3 are on. So let us see now. When can we write here? Does anyone know how to write over here in this diagram through this tab? Anyone knows?
Uh,
वो क्या था? Somebody had told me canvas. No, can I print copy paste in canvas?
ma'am, you can take the screenshot and paste it into Canvas.
Taking screenshot. Can I paste it in the canvas?
Yes, ma'am.
Yes,
Ma'am, you
ma'am.
can also open the whiteboard jam.
Yes, ma'am. Whiteboard jam through Google
अच्छा
Meet.
हाँ, ठीक है, हाँ white board है. Wait. Where is my- Can I pay? I can paste there, no?
Yes, ma'am.
Where did the whiteboard go? Where is crop over here? There's no crop. Sorry.
It will be option.
Where?
The three dots when you hover the image.
Okay. 3 dots. Okay. No, I get only duplicate and delete.
Try to drag the border.
Sorry, any one of you, please. Can't hear you. Who knows? I will just give you a sharing right. Please do it for me. Okay, forget. Can you see the diagram now?
Yes, ma'am.
Okay, I could write. Fine. No need to do this thing. Wait. Now see, what were we talking? What was the bit of C1? C1 was high, which is 1, and C2 was 0. Yes or no?
Yes,
Now,
ma'am.
when C1 was high, which is 1, and when C2 was 0, what did we read? We read that which transistors?
One and four.
Transistor 1 and 4 were off. That means 1 was having 0, 4 was
Ma'am,
having,
on, I think.
they were on or they were off?
On.
Okay, wait. So T1 and T4 were on, T2 and T3 were off. Okay, now let us check this. So when I have C1 as 1, what will get transmitted to T2?
One.
1.
I think we have read it wrong. Just a minute. Give me a second. T1 and T4 are off. Who said they are on? I was correct previously. T1 is 0. This is 0. This is 1. And this is also 1. Okay. Now see, when C1 is 1, what is getting transmitted to T2 as it is 1? Okay. Now when C1 is 1, what is getting transmitted to T4? It should go 1, but since I have an inverter, so it is getting transmitted as 0. Okay. Yes or no?
Yes, ma'am.
Okay. Now
Yes, ma'am.
let us talk about C2. When C2 is 0, what is getting transmitted at T1 as it is without inverter? 0. C2 is having 0, but what is getting transmitted to T3? It should go 0, but since it has a bubble, so it is getting transmitted 1. Which means when C1 and C2 are high and low, transistor T2 and T3 are used for storing. I am not using T1 and T2 for storing the data, which means जो 1 है they are used for storing the bits, जो 0 है they are not used for storing the bits. Now let us change the value and see when I change which transistors are working and which transistors remain inactive. When C1 is low and when C2 is high, what will happen? When C1 is 0, what will be the value of T2? It will be 0. What will be the value of T1? Sorry, T4, it will go like this. So the value 0 will become 1. Correct?
Yes,
Yes,
ma'am.
ma'am.
Ah.
Yes, ma'am.
When it is C2, when C2 is 1, C2 will go like this to T1 and it will stay 1. Correct?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now when C2 is 1 and when it has to go to T3, it will go like this. Your 1 will be changed to 0. So when your C1 and C2 value changes to low and high, your transistor T4 and transistor T1 will be operated, whereas your T3 and T2 will remain inactive. So this is how your SRAM works. First of all, what did we do is we have SRAM says that it should store the data in flip-flop. So to get a flip-flop effect, we have converted these transistor T1, T2, T3, T4 in a cross couple manner. So this cross couple has given us the effect of flip-flop. When they are cross couple, they will also work like cross couple. How they will work like cross couple is when the data is over here, it will go transmitted like this, and this data will go transmitted like this. If it is this C2, it will get transmitted like this in a cross couple, and it will get transmitted like this in a manner. Now when you change the bits to 0 and 1, according to that bits, only any two transistors will work, remaining two will be inactive. Now if I change this to 1 and 0, again any two will remain active and any two will remain inactive. So this is how your SRAM works. Are you clear now?
Yes, ma'am.
Yes, ma'am.
But when I talk about DRAM, wait, this is over now. Let me delete this. Can you see the screen?
No, ma'am.
Ma'am.
Okay. Can you see it now?
Yes, ma'am.
But now if you see DRAM, what is happening in DRAM? Can you see any such kind of transistors and all? No, there is only one transistor. You have one input, you have address line, your value will get stored, and the other one is ground for the negative. Okay. Now what is happening in both? We will be seeing that.
Ma'am,
Let us
what's
see.
T5 and T6 for in SRAM?
Sorry,
What's T5 and T6 for in SRAM?
they are used for address lines, just to pick up the address. एड्रेस लोगे तभी ये 01 समझेगा ना क्या है. 01 क्या है? डेटा है. डेटा किधर है? एड्रेस पे. तो एड्रेस कौन दे रहा है? ट्रांजिस्टर T5 एंड T6. कैन यू सी एड्रेस लाइंस कनेक्टेड टू T5 एंड T6?
Yes, ma'am.
हाँ, सो एड्रेस लाइंस जो T5 और T6 ट्रांजिस्टर्स को है, वो T5 और T6 ट्रांजिस्टर क्या कर रहे हैं? दे आर गिविंग द एड्रेसेस. ठीक है, जब भी C1 एक्टिवेटेड है तभी उसको हु विल गिव द मेमोरी एड्रेस? T5. C2 activated है तो who will give the memory address? T6. It is like that. Okay.
Yes, ma'am.
So any one is working at a time. Why? Because according to that I am activating C1 and C2. दोनों एक साथ high, a low नहीं है. एक high है तो एक low है. It is like that. Okay. What is there in DRAM? Can you see any such kind of number of transistors? No. Why? Because your DRAM doesn't work on a concept of flip-flop. It works on a concept of charge. Now what is charge? Everyone has ट्यूब लाइट्स एट आवर होम. ओके, हाउ इज दैट ट्यूब लाइट? हमने स्विच चालू किया, लाइट आएगा, बंद किया, लाइट चला जाएगा. मेनी अ टाइम्स some have you seen that there is a flicker in the light? ऐसे थोड़ा चालू बंद होता है, डिम होता है, and then it gets constant. Have you seen that effect any at time?
Yes.
That
Yes,
flickering.
ma'am.
Yeah. Why that flickering comes? Because your data is in the form of a charge. When the switch gets on, तो वो वायर में से क्या जाता है? चार्ज जाता है, करंट जाता है. ओके, जो करंट अगर एक ही शॉट में मिल गया तो वो फर्स्ट शॉट में ही लाइट ऑन हो जाएगा. अगर धीरे धीरे करंट पास हुआ तो इट विल फ्लिकर एंड देन इट विल display the light completely. So in DRAM, your data is stored in the form of a charge, current in a form of a charge. Therefore, we here make use of capacitors, whereas in SRAM, we don't make use of such current. We make use of direct a memory cell called as flip-flop. Okay. So if you see, 1 minute. Just a minute. So now we have seen SRAM where the data is stored in flip-flop. What it is written, we have four transistors which are cross-coupled and given the effect of the flip-flop. We have more two transistors which will just do the function of selecting the address lines. So what is told in SRAM? We do not require any kind of refreshing. Data is retained as long as there is a power, and the data is stored in flip-flop. So we have seen how the data is stored in flip-flop. Now what does this refreshing mean? Now I told you that in DRAM, your data is in the form of a charge which is current. Okay. So whenever you have a current, the data will be displayed. If there is no current, data won't be displayed. So what is happening in your DRAM? If I want continuously that the data should be shown to the user, I have to refresh. Refresh means how we refresh by pressing F5 to load that page again and again. Similarly, in capacitor, a mechanism of refreshing is used so that whatever data is there, that data should be displayed to the user as and when the user requires. So if now my data is 0 and if a user requests for that data, I should immediately refresh and show the user, and continuously keep on refreshing to make that 0 visible to the user until the user does not stop. But that case does not happen in SRAM. Why? Because I am not using capacitor and the data is neither stored in a form of a charge. Since here I am using a flip-flop, so I do not require that refreshing to be done. Whereas that refreshing requires to be done in the DRAM, because I am storing a data there in a form of a charge inside a capacitor. So that charge should retain as and when the user requires. So to retainment of that charge, the refreshment is done in the SRAM and it is not done in the it is done in the DRAM and it is not done in the SRAM. So what is happening? Data is retained as long as there is a power. So जब तक power है तब तक you will get a data. Whereas in DRAM you have to continuously refresh for the power as well as you have to refresh for the data. Okay. What is DRAM? The presence of the data is either 0 or 1. Same. Here also in flip-flop it will be either 0 or 1. In DRAM also it will be either 0 or 1. But here it is in the form of flip-flop. Here it will be in the form of a charge. So since it is in the form of a charge, we are going to require that refreshment. Since we do not have a charge in SRAM, therefore there is no refreshment required. It is less expensive, it is more expensive, because buying a flip-flop and storing the data in flip-flop is much more expensive as compared to your capacitor. Whenever a refreshment is done, at that time operation is not performed. What kind of operation? Read write operation is not performed whenever that refreshment is done. तो ये read हो गया, उसके बाद refresh होगा, फिर write होगा. Again refresh, read. Again refresh, write. But when it is reading, it cannot refresh at the same time. Okay. Where your DRAM is used, your DRAM is used in your main memory, and where your SRAM is used, it is used inside your cache memory. Is this SRAM working, DRAM diagram and DRAM working clear to you?
Yes, ma'am.
Everybody?
Yes, ma'am.
Yes.
Okay. So tomorrow again we will continue with the remaining part. So I am stopping here so that you do not get much confused in the other memories ahead. So we have seen SRAM, diagram of SRAM, working of SRAM, DRAM, diagram of SRAM and working of DRAM. Apart from that, we have also seen characteristics which all the memory systems can have. Okay.
Yes,
Yes,
ma'am.
ma'am.
Give your attendance. Faizan.